I'm Jan Miller, CTO of Threat Analysis, and today I will be presenting to you leveraging Sandbox to better understand your threat landscape. So let's dive in. So what are the talking points today? On the one section, we really want to show some insights that we've learned from understanding the data on our free community site, FileScan.io, that runs the MetaDefender Sandbox technology to extract IoCs from threats. So we're going to have some AI and threat landscape insights for you guys. The adaptive sandbox technology will be covered in the second portion of this talk. So looking forward to presenting that to everybody. So how much stage 1 malware is actually AI enabled? That's a question we asked ourselves. What is stage 1? So in today's world, attacks are typically multi-staged. That means on stage 1, you have typically a phishing email, a productivity file, like an Office document enabled with a malicious macro code. You might have a phishing PDF with JavaScript inside. So what we really did with the rise of LLMs and OpenAI and GPT and these kind of AI techs, we looked at the stage 1 samples, like a random sample set that we pulled from FileScan.io, and really tried to figure out how much of the content that we see, like in the email body or in the PDF or document, is actually AI generated, i.e., how much AI is being used by threat actors today. And interestingly enough, we really see a spike in AI generated content. Some of the observations we had were that we saw a 50% increase in AI generated content for PDFs right after the GPT 3.5 release, which was the most popular one that was driving the whole LLM movement. We didn't see so much of a spike in Office documents and emails, though overall we see a strong upward trend in AI generated content, specifically for phishing attacks, because it makes the phishing attacks and social spear phishing attacks and social engineering attacks much more realistic, because you get rid of typos. It can be tailored customly in different languages. It's definitely a tool of the trade that we see today. What other insights do we see looking at the data on FileScan.io? So first of all, FileScan.io, it's a free community service exposing our sandbox technology, and also has a very large database of IoCs. So you can use it for threat hunting and threat intelligence purposes today. Very popular. We have 11,000 active users, currently 3 million reports that are curated from different sources, not only from the community, but we also ingest samples from AbuseCH and other services. And it really allows us to gain a lot of insights into the tools, the file types that we see, certain malware families that are trending, and the ideas that will give a lot of actionable intelligence back to our user base. Looking at the data, here we were mapping all the sandbox reports, threat indicators, we were mapping them to the MITRE ATT&CK framework. So in general, our sandbox covers about 60% of the MITRE techniques and about 30% of all the sub-techniques that we see in the MITRE ATT&CK framework. One thing that we saw in terms of frequency is that software packing, also discovery. So something you would see in the stage 1 where there's reconnaissance happening on the endpoints. We really see that in the threats. So not a surprise there. A nice conclusion we have here is if we see a lot of software packing in the stage 1 or on malware samples that are in stage 2, what does it tell us? It tells us static analysis is not enough, because a statically packed sample is basically a high entropy data blob. You can't extract anything useful. You really need a sandbox. You really need dynamic analysis to look inside of the file. So it reconfirmed basically for us that sandboxing as a technology is not dead, and it works very well together with static analysis. In terms of packers that we saw for executables. First of all, we support a variety of different packers. So we have a generic unpacking stage, but we also have specific unpackers for certain special types of packers. We also support AutoWit to executable decompilation and PyInstaller executable decompression. So what was really interesting here is that we see a trend towards usage of more sophisticated packers like VMProtect, which comes with a virtual machine inside, really also underlining and reconfirming to us that focusing on sophisticated unpacking to look inside of executables is really a very useful technology. Another trend that we saw is regarding compilers and languages that we saw. So there's a big uptick in usage of more niche languages like Visual Basic and Delphi. We also see Golang and some VBNet that's being used. So that requires more specialized tools that can understand API call chains and behavioral flows in these executables. It also makes reverse engineering for malware analysts more difficult, right? Because they typically use different runtime libraries, and it's not as straightforward as a very classic C compiled binary. In terms of non-executable file type trends, we really see an uptick in PDF files. Not a surprise there because the PDF file structure has a lot of complex layers. There's a lot of ways to embed secondary executable scripts or action forms in this file structure and bypass really static analysis technology like AVs. We also saw some HTML smuggling throughout the year and a lot of QR code usage. So our Sandbox technology has really been focusing on analyzing these more sophisticated attacks. In terms of HTML, we can render that in the browser and then perform image analysis on the rendered HTML. All right, moving to the Sandbox. The traditional Sandbox, we see it more as a forensic analysis tool because it's locked into an application stack. It has high resource usage, so you really need to spend a lot of maintenance on the infrastructure. It's slow. It requires minutes and not seconds to analyze a file. And again, you lock yourself into an application stack, so very sophisticated malware that requires very special conditions to execute. It might just not execute, right? Because if there's a targeted attack targeting a specific region and your Sandbox VM is the English language, but not the Hebrew language or some other language, it obviously won't execute. So our emulation-based approach is much more agile and versatile. We can adapt the environment based on the needs of the malware to really have a higher success rate at detonating and blowing up the malware. It's very fast. It has very thin virtualization layer, very low in terms of resource usage, and scalable. Here's another quick side-by-side table. So on the left side, and we try to categorize these two fundamental Sandbox technologies, the emulation-based ones and the more traditional virtual machine-based sandboxes. In terms of speed, big difference there. In terms of scalability as well. Typically, a traditional VM isn't cloud native because nested virtualization is not allowed. The emulation-based Sandbox is fully cloud native, can run in a Kubernetes cluster, and is horizontally scalable. As mentioned, in terms of resource usage, we see up to 100 times more resource efficiency in the emulation-based Sandbox, which translates to a lot of cost savings for the end users. Each Sandbox has its own use case, obviously. If I'm in incident response, I'm doing forensic analysis, I have a golden image. I might still, for a manual analysis task, use a more traditional VM-based sandbox. However, if I'm at the perimeter, I'm scanning thousands of files a day, coming in through the network, through the email, I really need an emulation-based sandbox. In terms of the file processing funnel, this is how we view it. There's different stages in the processing funnel. So layer 0 is really a millisecond check. It's a reputation check, typically utilizing a threat intelligence service. That can be a cloud service. It could also be a local reputation database that gets updated at a high frequency. Then you really move to a static, that's like a hash check, right? And then you move to the static analysis layer. Typically, this is where you see the AV engines. This is where we also position a special speed mode that we have in the MetaDefender sandbox. Once you pass through the static analysis layer, depending on if you found the threat or not, you really move to a dynamic fast path layer. That's where you perform emulation. That's where you have the adaptive sandboxing technology. Really a very lightweight virtualization layer. It's still a very safe way to detonate the malware and uncover new undetected threats. And that's really automated malware analysis pipeline. Layer 3, that's more of the manual analysis that happens in the SOC as part of an incident response. So one thing we see with the sandbox is that it's not just a technology for dynamic analysis, it's really a holistic malware analysis platform to tackle these multi-staged attacks and the sophisticated attacks that we see. That means we have a combination of different types of analysis technologies. So we perform a deep structure analysis, we perform static analysis, we do content analysis, like with rendering URLs in the browser, doing image analysis, doing more sophisticated phishing detection through those type of analysis stages. But we also perform dynamic analysis in the emulators, and in case of executables, full binary analysis as well. So think of the MetaDefender sandbox as a small orchestration layer. It combines a variety of technologies together to maximize not only the detection of unknown threats, but also the IoC extraction, as well as TTP tool and tool extraction and accurate malware family classification. It works together, so there's a feedback loop. The sandbox can extract embedded hidden IoCs, and then we can utilize reputation services in the cloud to really leverage a very large database of real-time threat intelligence data to enhance the efficacy of the overall system. So in terms of efficacy, we did deep dive that as well, also using in the wild malware samples in the community. So we really see an amazing efficacy of the full solution. How is that explained? So what we did here is we compared the sandbox in an air-gapped environment, so it can't utilize any cloud reputation service. We compared that detection efficacy to only the reputation service on the input hash. Both of them are what we say mid. They're not perfect, they're still good. However, if you take all the hidden IoCs that are extracted from the sandbox and also leverage the reputation services to check against those hidden IoCs, the full solution, that's what you see on the left infographic here on the right column, you really get to almost 100% detection efficacy. Also, in terms of noise ratio, we really see a very low false positive rate for stage 1 for documents and scripts, so that you don't suffer from alert fatigue. Here's just one quick example of such a multi-layered attack detection in the sandbox. So here we created a malware sample that is simulating an actual APT attack from Mustang Panda that we observed in May 2024. We see here are various stages. PowerShell gets spawned, a Windows task gets scheduled, then again starts executing another HTML application, which spawns another PowerShell. and uses a set of different tools to triage and fingerprint the system, something that threat actors really do in preparation of the second attack. So using the emulation, the virtualization technology really allows us to go really deep, even in multi-layered attacks, and do that in seconds and not in minutes. Here's another example where we see usage of an indirect command execution using the 4-files system tool in a Windows shortcut file. Also a nice trick to bypass a lot of security tools. And also we see a scheduled task. So a typical evasion technique to bypass sandboxes, scheduling the next stage to run 30 minutes later. Most sandbox systems only have a couple minutes to observe all the behavior, so it really effectively bypasses a lot of sandbox systems. Not so in the emulator, because we're in full control of the system tools in the OS emulation layer. If we see a Windows task schedule, we can just trigger it immediately or fast forward the system time. Here's another 2 examples. We see geofencing a lot. So some malware only executes based on the external IP geolocation in a certain region. We can overcome that by performing data flow analysis in the emulators and then manipulating the control flow to really pathfind our way down the attack chain and extract as many IoCs and TTPs as possible. That was it from my side. Thank you for joining today's webinar. If you still have any questions or would like to speak to someone at OPSWAT, please scan the QR code on the screen or send us a note in the chat.